Hello everyone, welcome to the course on chemistry. In that we are discussing about electrochemistry. In the previous video, we have studied how to find the molar conductivities for strong electrolytes. By plotting the graph of concentration and conductivity, we can able to find the molar conductivity for strong electrolytes. But for weak electrolytes, how we can determine the molar conductivity? That we will study in this video. The limiting molar conductivities for weak electrolytes cannot be determined by extrapolation of curve of lambda m versus square root of c. That is molar conductivity versus square root of concentration. Now limiting molar conductivity na weak electrolytes ಗೆ graph through find out ಮಾಡಲಿಕ್ಕೆ ಬರುವುದಿಲ್ಲ. It is because as the curve becomes almost parallel to y-axis as concentration approaches 0. ನಾವು ಗ್ರಾಫ್ ಪ್ಲಾಟ್ ಮಾಡಿದಾಗ ಆ ಕರ್ವ್ ಏನು ಸಿಗುತ್ತಲ್ಲ ನಮಗೆ by plotting the graph of lambda m versus square root of c for weak electrolytes. In previous video, you have seen the plot of lambda m versus square root of c for acetic acid. There you have got the curve. If we decrease the concentration, means if the concentration approaches to 0, then that curve becomes almost parallel to y-axis. Y-axis ಗೆ parallel ಆಗಿಬಿಡುತ್ತೆ. So if it is parallel, then it will not meet on the y-axis and hence we cannot able to determine the limiting molar conductivity for weak electrolytes. Okay, ಆ parallel ಆಗೋದ್ರಿಂದ ಅದು intersect ಆಗೋದಿಲ್ಲ y-axis ಮೇಲೆ. So we can't get the limiting molar conductivity for weak electrolytes. Then how to find the limiting molar conductivity for weak electrolytes? Graph plot ಮಾಡಿದ್ರು limiting molar conductivity find out ಮಾಡ್ಲಿಕ್ಕೆ ಬರೋದಿಲ್ಲ. ಬಟ್ ಯಾವ ವೇ ಒಳಗೆ ನಾವು limiting molar conductivity find out ಮಾಡಬೇಕು for weak electrolytes? That can be determined by using one of the important law, that is KOHLRAUSCH'S law of independent migration of ions. KOHLRAUSCH'S law use ಮಾಡಿಕೊಂಡು weak electrolytes the limiting molar conductivity find out ಮಾಡಬಹುದು. So how? Let's see what the KOHLRAUSCH'S law states. It states that limiting molar conductivity of an electrolyte can be represented as the sum of the individual contributions of the anion and cation of the electrolyte. ಏನು ಹೇಳುತ್ತಪ್ಪ ಅಂತ ಹೇಳಿದ್ರ, if we add any solute to the solvent, ಯಾವುದೋ ಒಂದು solute which is an electrolyte, electrolyte ಅನ್ನ ಆಡ್ ಮಾಡಿದಾಗ ಒಂದು ಸೊಲ್ಯೂಷನ್ ಒಳಗ it will dissociate into ions. Ions ಆಗಿ ಏನಾಗುತ್ತೆ, dissociate ಆಗುತ್ತೆ. Then those ions will conduct the electricity and the limiting molar conductivity of that electrolyte can be calculated by taking the sum of individual contributions of anion and cation. Anion ಎಷ್ಟು ಕಂಡಕ್ಟಿವಿಟಿ ತೋರಿಸುತ್ತೆ, ಕ್ಯಾಟಯಾನ್ ಎಷ್ಟು ಕಂಡಕ್ಟಿವಿಟಿ ತೋರಿಸುತ್ತೆ, ಎರಡರದು ಸಮ್ ಮಾಡಿದ್ವಿ ಅಂತ ಹೇಳಿದ್ರೆ ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಈಸ್ ಡಿಟರ್ಮೈನ್ಡ್ ಅಂತ ಹೇಳ್ತೀವಿ, ವಿಚ್ ಈಸ್ ಸ್ಟೇಟೆಡ್ ಬೈ KOHLRAUSCH, which is the name of scientist. Okay, he has given this statement for limiting molar conductivity of an electrolyte. Okay, and it is given as lambda m naught is equal to V plus lambda plus naught plus V minus lambda minus naught. Here lambda naught and lambda naught minus are the limiting molar conductivities of cations and anions. Lambda naught plus ಮತ್ತು lambda naught minus ಏನು represent ಮಾಡುತ್ರಿ? Limiting molar conductivities of cations and anions. And V plus and V minus, they will represent the number of cations and anions per formula of electrolyte. Suppose if we take NaCl, ಈಗ NaCl ತಗೊಂಡ್ವಿ ಅಂತ ಹೇಳಿದ್ರೆ, which is an electrolyte. Limiting molar conductivity of NaCl is equal to ಏನು ಬರಿಬೋದು? Na plus limiting molar conductivity of Na plus, that is lambda Na plus plus lambda Cl minus ಅಂತ ಬರೀತೀರಿ. ಒಂದು cation ಇನ್ನೊಂದು anion. The number of cations and anions is 1 only. V plus ಅಂತ ಹೇಳಿದ್ರೆ ಏನು ತಗೊಂತೀರಿ? 1 ತಗೊಂತೀರಿ. V minus ಅಂತ ಹೇಳಿದ್ರು 1. ಒಂದು cation ಇರುತ್ತೆ, ಒಂದು anion ಇರುತ್ತೆ. Suppose if we take CaCl2, CaCl2 ಅಂತ ತಗೊಂಡ್ರೆ ಅವಾಗ ಏನು ಬರಿತೀವಿ? lambda Ca plus 2 naught plus lambda Cl minus naught, but V minus value ಏನಿರುತ್ತೆ? 2, because number of anions is 2. So here we will take the 2 and here we will write lambda Cl minus. So this is how we can find the limiting molar conductivity of electrolyte according to KOHLRAUSCH'S law. Okay, so how to find the limiting molar conductivity of the electrolyte, that we will study. So before going to that, here we will see some examples. That is lambda naught NaCl is equal to lambda naught Na plus lambda naught Cl minus. Okay, means limiting molar conductivity of NaCl is equal to the sum of limiting molar conductivities of cations and anions ಅಂತ ಹೇಳ್ತೀರಿ. lambda naught Na plus and lambda naught Cl minus. And in the similar manner, if we calculate the limiting molar conductivities for HCl, how we will calculate that? Limiting molar conductivity of H plus and limiting molar conductivity of Cl minus. So it is not A minus, it is Cl minus. And similarly for sodium acetate, we can write it as lambda naught CH3COO minus plus lambda naught Na plus. In this manner, we will calculate the limiting molar conductivities of an electrolyte by taking the sum of the cations and anions limiting molar conductivities. Now we will see the applications of KOHLRAUSCH'S law, where this KOHLRAUSCH'S law has been used. The first application is calculation of molar conductivities of weak electrolyte at infinite dilution. So now main application KOHLRAUSCH'S law ಯಾವ್ದು ನೋಡ್ತೀವಿ? Finding the limiting molar conductivities of weak electrolyte. Because for strong electrolyte, we will calculate the molar conductivity by plotting the graph. But for weak electrolyte, we will apply the KOHLRAUSCH'S law. How to calculate that limiting molar conductivity? Let's see one example. Calculate molar conductivity at infinite dilution of acetic acid. Acetic acid is a weak electrolyte. If molar conductivity at infinite dilution, that means limiting molar conductivity of CH3COONA, HCl and NaCl are X, Y and Z. ಇಲ್ಲಿ ಏನು ಕೊಟ್ಟಾರ್ರಿ? you need to find the limiting molar conductivity of acetic acid, and they have given the molar conductivity of sodium acetate, HCl and NaCl as X, Y and Z. E values ಕೊಟ್ಟಾರೆ. In general they have given the values X, Y and Z. You need to find the limiting molar conductivity of acetic acid. So what we will do? ಏನು ಮಾಡಬಹುದು? As you know, limiting molar conductivity according to KOHLRAUSCH'S law, it is lambda naught CS3COO minus plus lambda naught H plus. ಎರಡು ಅಯಾನ್ಸ್ ಕೊಡ್ತಾವ್ರಿ. ಪಾಸಿಟಿವ್ ಅಯಾನ್ ಯಾವುದು ಎಸ್ಟಿಕ್ ಆಸಿಡ್ ಒಳಗ H plus, negative ion ಯಾವ್ದ್ರಿ CS3COO minus. Okay, it will dissociate into the cation and anion. Now, as you know, limiting molar conductivity of CS3COO Na is equal to lambda naught CS3COO minus plus lambda naught Na plus. ಇಲ್ಲಿ ನೋಡ್ರಿ, ನಿಮಗೆ CS3COO minus ಅದರದ್ದು ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಿಲ್ಲ and limiting molar conductivity of H plus ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಿಲ್ಲ. ನೀವು ಏನು ಮಾಡಬೇಕು, ಈ ಗಿವನ್ ವ್ಯಾಲ್ಯೂಸ್ HCl, NaCl and sodium acetate ಈ ಮೂರರದ್ದು ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟೀಸ್ ತಗೊಂಡು ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀರಿ? ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆಫ್ ಅಸಿಟಿಕ್ ಆಸಿಡ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀರಿ. ಸೊ ಬಿಫೋರ್ ಗೋಯಿಂಗ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ್ಯಾಟ್, ಫಸ್ಟ್ write down the limiting molar conductivities of these three electrolytes. Then limiting molar conductivity of HCl is given as lambda naught H plus plus lambda naught Cl minus. Okay, again it is Cl minus. And similarly for NaCl, it is lambda naught Na plus plus lambda naught Cl minus. So this is how we can calculate the limiting molar conductivities for sodium acetate, HCl and NaCl. Now what we want? We want CS3COOH molar conductivity. For that, we will write this equation as lambda naught CS3COO minus plus lambda naught Na plus. That is given here. Okay, let us consider this one as X. Okay, then next add the Y, that is lambda naught H plus plus lambda naught Cl minus. That is the limiting molar conductivity of HCl, and minus NaCl, lambda naught Na plus plus lambda naught Cl minus. Why we have written like this? X plus Y minus Z. ಈ ರೀತಿ ಯಾಕೆ ಬರೀಬೇಕು? ಈಗ ನೋಡ್ರಿ, ನಮಗೆ CS3COO minus lambda naught H plus ಬೇಕು. ಅದು ಬರಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ we know the values of these three. ಈ ಮೂರರದ್ದು ವ್ಯಾಲ್ಯೂಸ್ ಗೊತ್ತು, that is X, Y and Z. So here we will add and subtract depending upon this value. ಓಕೆ, ನಮಗೆ ಈ ವ್ಯಾಲ್ಯೂ ಸಿಗಬೇಕು, CS3COO minus ಪ್ಲಸ್ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ H ಪ್ಲಸ್. ಇವು ಮೂರನ್ನು ಕೂಡಿಸಿದಾಗ ನನಗೆ ಲಾಸ್ಟಿಗೆ ಏನು ಸಿಗಬೇಕು? ಆನ್ಸರ್ ಇದು ಸಿಗಬೇಕು. ಏನಾಗುತ್ತೆ ನೋಡ್ರಿ, ಇಲ್ಲಿ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ CS3COO minus ಪ್ಲಸ್ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ Na ಪ್ಲಸ್. ಇಲ್ಲಿ ಏನದ ರೀ, ಮೈನಸ್ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ Na ಪ್ಲಸ್. ಇಫ್ ವಿ ಮಲ್ಟಿಪ್ಲೈ ದ್ಯಾಟ್ ಮೈನಸ್ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ Na ಪ್ಲಸ್ ಆಗುತ್ತೆ ಇಲ್ಲಿ. ಓಕೆ, ದಿಸ್ ವ್ಯಾಲ್ಯೂ. ಸೊ this is minus lambda naught Na plus and this is plus lambda naught Na plus. Both will get cancel out. You have to cancel ಆಗ್ತವ್ರಿ. Next ಏನು ಉಳಿತು? lambda naught Cl minus, and here again minus into plus, again it becomes minus lambda naught Cl minus. So minus lambda naught Cl minus and plus lambda naught Cl minus will get cancel out. What will remain? ಏನು ಉಳಿಯುತ್ತೆ ಹೇಳ್ರಿ ಇಲ್ಲಿ? CS3COO minus plus lambda naught H plus. Depending upon what they have given, you have to add or subtract these things. ಈ ಅಯಾನ್ಸನ್ನು ನೀವು ಏನು ಮಾಡಬೇಕು, ಇಲ್ಲಿ ನಿಮಗೇನು ಬೇಕಾಗಿರುತ್ತೆ ಆ ಬೇಸಿಸ್ ಮೇಲೆ ಪ್ಲಸ್ ಮಾಡಬೇಕು ಮೈನಸ್ ಮಾಡಬೇಕು ಅನ್ನೋದನ್ನು ಡಿಸೈಡ್ ಮಾಡಬೇಕು. ಹಿಯರ್ ಇಫ್ ವಿ ಆ್ಯಡ್ ಎಕ್ಸ್ ಆ್ಯಂಡ್ ವೈ and if we subtract z, we will get the limiting molar conductivity of acetic acid. Hence I have taken like this. So suppose if x value is 2 and y value is 6, okay, and z value is 2, what I will get? X iddale ಏನು ಹಾಕೋದು 2, y ಇದ್ದಲ್ಲೇ 6 and z ಇದ್ದಲ್ಲೇ 2. ಏನಾಗುತ್ತೆ 2 plus 6 minus 2. So 2 to get cancel out, the answer will be 6. So that is the limiting molar conductivity. So here they have not mentioned any values x, y, z. In general they have given. Instead of that, if they have given any other values, then you can substitute those values in this equation and you can easily get the limiting molar conductivity for weak electrolyte. So this is one of the important applications of KOHLRAUSCH'S law. Okay, here at finally you can write like this. So finally ನೀವು ಏನು ಮಾಡ್ಬೋದು, limiting molar conductivity ಈ ರೀತಿ ಬರಿಬೋದು. lambda naught CS3CO Na plus lambda naught HCl minus lambda naught NaCl. ಈ ವ್ಯಾಲ್ಯೂನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರಿ ಅಂತ ಹೇಳಿದ್ರೆ ನಿಮಗೆ ಏನು ಸಿಗುತ್ತೆ, ಆನ್ಸರ್ ಸಿಗುತ್ತೆ. Okay, so second one, determination of degree of dissociation of weak electrolytes. Second application ಏನು, degree of dissociation of weak electrolytes determine ಮಾಡಕ್ಕೆ help ಮಾಡುತ್ತೆ. Degree of dissociation means to what extent the ions will undergo dissociation in the solution. That is nothing but degree of dissociation. Ions ಯಾವುದೋ ಒಂದು ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ನೀವು ಸೊಲ್ಯೂಷನ್ ಒಳಗೆ ಡಿಸಾಲ್ವ್ ಮಾಡಿದಾಗ ಅಲ್ಲಿ ಅಯಾನ್ಸ್ ಆಗಿ ಡಿಸೋಸಿಯೇಟ್ ಆಗಬೇಕು. ಟು ವಾಟ್ ಎಕ್ಸ್ಟೆಂಟ್ ದೇ ವಿಲ್ ಗೆಟ್ ಡಿಸೋಸಿಯೇಟ್. ಓಕೆ, ಸೊ 100% ಡಿಸೋಸಿಯೇಟ್ ಆಗ್ಬೋದು ಅಥವಾ 75% ಡಿಸೋಸಿಯೇಟ್ ಆಗ್ಬೋದು, 50% ಡಿಸೋಸಿಯೇಟ್ ಆಗ್ಬೋದು, ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ದಿ ನೇಚರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್. And it is calculated by molar conductivity at concentration C and molar conductivity at infinite dilution. ಎರಡು ಡಿವೈಡ್ ಮಾಡಿದ್ರಿ ಅಂತ ಹೇಳಿದ್ರೆ ನಿಮಗೆ ಏನು ಸಿಗುತ್ತೆ, alpha, that is degree of dissociation, that can be calculated. Then third one is determination of dissociation constant K of weak electrolytes. Dissociation constant of weak electrolytes determine ಮಾಡಬೇಕಾದ್ರೆ help ಆಗುತ್ತೆ. How you determine the dissociation constant? It is denoted as K. It can be calculated as K is equal to C alpha square divided by 1 minus alpha. Here C is concentration and alpha is degree of dissociation. And as you know, alpha the value ಏನ್ರಿ, alpha value ನಿಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತು, lambda C and lambda naught. Okay, substitute the value of alpha in this equation. So you will get K is equal to C alpha square ಅಂತ ಹೇಳಿದ್ರೆ ಏನ್ರಿ, lambda C divided by lambda infinity divided by 1 minus lambda C divided by lambda infinity. Upon simplification, you will get the answer. So this is how we can able to determine the dissociation constant for weak electrolytes. So these are the very important 3 applications of KOHLRAUSCH'S law.